So good morning, everyone. Today we can discuss today's class joint, marginal, and conditional distribution. So in the joint, marginal, and conditional distribution we are taking here today. Joint, marginal, conditional distribution for discrete random variables, and a joint, marginal, and conditional distribution for continuous random variables. We can discuss today two topics. One is discrete random variable and one is continuous random variable. We have to discuss here today. Um, so therefore, this define how to define here joint, marginal, and conditional distribution for discrete and continuous random variables. Distinguish between discrete and continuous random variables we are taking here. So in this bivariate distribution can be defined for two kinds of the random variables, discrete and continuous. Already I told there are three concepts of joint, marginal, and conditional for both discrete and continuous random variables. So joint, marginal, and conditional distributions for discrete random variables. In the joint probability mass function, let x and y, two discrete random variables x1, x2, x3, and x4, and x5, and up to so on xn we are taking here. So suppose the two random variables, what is the two random variables x and y? So x1 to xn and y1 to yn. We are taking x5 and y5, x10 and y10, and up to the nth condition in x and m condition in y, we can take the respectively here. Then the function pxy is called as a joint probability PMF, joint probability mass function of random variable x and y. P of xy greater than or equal to 0 or xy, summation of x, summation of y, px comma y is equal to 1. Suppose summation of x and summation of y, p of x is equal. When we are doing y with y and then we are doing summation of x, so the value should be 1. We have to learn in this unit. So marginal probability function of x and y. Now let we are taking x and y be a two-dimensional discrete random variable which takes countable number of values. Then the marginal probability function x and y are denoted by p of x and p of y and are calculated as follows here. That is, p of xi is equal to p of capital X is equal to xi. Is equal to p of xi is equal to xi and y is equal to y. So xi taking in the part of x is equal to x, xi taking that p of I is equal to y1. Then x is equal to xi taking, then y is equal to y2. Then x is equal to xi taking, y is equal to y3. Then x is equal to xi and y is equal to y4. That up to x is equal to xi, that is y. The term is I'm already told y1, y2, y3, y4, ym. We are taking here. Just a minute. So p x x y y ym. So and we taking p yj. So y is equal to yj. So therefore y xi is వాడినప్పుడు y లో j ని వాడతాం. So xi is equal to yij. So x1 that is equal to yij. x2 yij. x3 yij. That is xn. అంటే టాప్ లో xi తీసుకుంటూ y1 y2 y3 y4 up to ym తీసుకుంటాం. So x is equal to xi, y is equal to yj, x is equal to x2, x3, x4 అంటే అక్కడ y is equal to yj తీసుకుంటే we are writing here p ij P1j plus P2j plus P3j plus P4j plus Pnj, summation of I is equal to 1 to Pij, that is Pj. Then conditional probability function of x and y we are taking here. Let x and y, let x comma y be two-dimensional discrete random variables here. Then the conditional probability function of x is given, x given, and y, x given y, and given y given x, x is given y, y is given x, defined as follows here. See here, all of you. Pxy by px of x is equal to y is equal to y, px of xi y yj, y is equal to yj, provided y equal to y, I not equal to 0. So py by x is equal to py by x by x. So yj xi by, so P is equal to what we are taking, y capital, y is equal to yj capital, x is equal to xi, y capital, P is equal to xi. So this is a provide of x is equal to xi dot. So the denominator equal to 0, the value is totally 0. So the denominator is not equal to 0, then we can find the value. The numerator, it should be minus or plus, it should be 0. We can't do this, but then the denominator is 0, the value should be 0 here. Then joint marginal conditional distribution for continuous random variables. Joint probability density function. Joint probability density function we are taking here. Let x and y be two continuous random variables taking all possible values within a given interval or image. Then the function f of xy. So we are taking the function f of xy is called f of xy in the margin image in the function, that is called as the joint probability density function of random variables x and y. If it is satisfied the following two conditions, that is the first condition is f of x greater than or y equal to 0, then integration of x and integration of y, integration of x and integration of y, f of x by dx dy. So first we can do that integration of y dy, then after the coming the value integration of x dx. Otherwise integration of x dx, after that integration of y dy, both the values we are integrating from the above part, so it should be make as 1. So marginal density function of x and y. So marginal probability density function, let xy be two random variables with a joint probability density function. You know that f of xy, then the general margin, then the marginal probability function of random variables x and y. Therefore, f of x comma f of y is defined as follows here. F of x is equal to integration of y f of x y dy, f of y integration of x f of x y dx. So x తో చేసినప్పుడు dx వాడతాం, y తో చేసినప్పుడు dy వాడతాం. I already told in MDF marginal probability, PDF marginal probability density function in x and y. What is the conditional probability? In marginal probability density function, we are taking f of x is equal to integration of y f of x dy, f of y is equal to integration of f of x y dx. Then conditional probability density function of x and y. Let x were two-dimensional continuous random variables, then the conditional probability function of x and y given are defined as follows here: fx by y, f of xy by f of xy by f of y, and f of y by x, that is f of xy by f of x. We are writing here. Joint marginal and conditional distribution functions. Let xy be a two-dimensional random variable. Then the joint distribution function of x and y is denoted as f of xy. So therefore, f of xy is called px less than x, pxy less than r. Why we are taking here? So what we are taking x less than r, x and y less than r, y taking here. So condition is satisfying here. The marginal distribution function x and y denoted as f of x and f of y. It is f of x is equal to p of x less than r. So x, that is capital X less than or equal to x, capital Y less than or equal to infinity. Why? Because it is less than or x to infinity we are taking here. Then f of y, y less than or equal to y, then y less than or equal to y, then y less than or equal to infinity also we are taking here. Then the conditional distribution function x and y are denoted f of x by f of y by x, f of x by p x less than or x by y by y, y by x p x y less than or equal to y, x is equal to x. We are taking these conditions. You can follow in the problems here. See here, the joint points of the random variables x and y given. X is equal to y and y is equal to 0, 2 by 9. X is equal to 0 and y is equal to 1, 0 to 1, 1 by 9. 1 to 0, 1 to 0, 1 by 9. And 1 to 1, 5 by 9. So find the marginal conditional probability of x and y. The given probability, how to follow in the table, we have to discuss here. The marginal probability is here. See here, all of you, very crucial. See here. X is equal to 0. See here, x is equal to 0. This is 3 by 9. Y is equal to 1. This is 6 by 9. Both are same. 2, 1 plus 1, 3 by 9. 1 plus 1, 6 by 9. 2 plus 1, 3 by 9. 5 so both the columns and rows should be equal. Then only it should be 1. So the value should be same. Y is equal to 0. So y is equal to 0. We have to take here 3 by 9 and 6 by 9. Both the values are same here. What the finding the values here. So the conditional probabilities of x and y given are calculated as follows here. So here already I told you x and y we can discuss one by one. X is equal to x and x, that is x is equal to x, this one. This is x is equal to x and y is equal to y, x, y. X is equal to 0, y is equal to 0. I'm going to the top. X is equal to 0. X is equal to 0, y is equal to 0. See here. X is equal to 0 and y is equal to 0, 2 by 9. You see here. Y is equal to 0. Y is equal to 0. This is 3 by 9. So 9, 9 cancel. Numerator and denominator 9, 9 cancel. It is 2 by 3. Right? Then x is equal to 0, y is equal to 1. X is equal to 0, y is equal to 1. 1 by x is equal to 0, that is 1 by 9 and 6 by 9. This is 1 by 9. This is 6 by 9. 1 by 9, 6 by 9. 9, 9 get cancelled here 1 by 6. So 0, 0, 0, 1 is over. Then x is equal to 1. X is equal to 1. We are taking 1 by 9 by 3 by 9. See here 1 by 9 by 3 by 9. So 1 by 3. 1. Out it is 3 by 9. First we are taking in the x value, we are taking here the 1 by 9 and 3 by 9. Then 5 by 9 and 6 by 9. See here 5 by 9, 6 by 9. Then 5 by 9, 6 by 9. So that is 5 by 6. All the 4 values getting here. Similarly, we are taking x is over, x is equal to 0, 0, 1, 1. Then y is equal to 0, 0 and 1, 1 also we have to take it. That's the 4 values also must and should take here. X is equal to, in the table, x is equal to 0, 0. 0, 0, 0, 1, 1, 0, x is equal to 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. Again, we are taking y condition. Again, similarly, y taking y is equal to 0, x is equal to 0, y is equal to 0, x is equal to 0. So y is equal to 0 and x is equal to 0. So you know that 2 by 9. See here, y is equal to 0, that is 2 by 9 by 3 by 9. P of x is equal to in the row. P of x is equal to this is, you have to see here 2 by 9 and 3 by 9 and 1 by 9 and 6 by 9. 1 by 9 and 6 by 9. We are taking here the same condition. 1 by 9, 1 by 9, 1 by 9 by 3 by 9, 5 by 9 by 6 by 9. 1 లో తీసుకుంటున్నాం 1 1 లో తీసుకుంటున్నాం 1 0 అయిపోయింది ఇక్కడ. So again we are taking here 1 by 9, 3 by 9. 1 లో 0, 1 లో 0, 1 by 9, 1 లో 5 by 9, 1 by 9, 5 by 9. ఇక్కడ చూడండి 1 by 9 and 5 by 9. So values are 3 by 9, 6 by 9, and after the simplification, we are finding the values here. It is a very the table format they given here. So very we can easily find out. Without table form, they will given how we can find. See here. The joint probability random. Joint random variables x and y is given f of x to x plus y by 3, 0, 0 less than x less than 2, 0 less than or equal to y less than or equal to, all are less than or equal to 0 less than or equal to x less than or equal to 0 less than or equal to y less than or equal to 2. Find the marginal conditional density functions of x and y we are taking here. F of x we are taking here. So see here already I told you the earlier one, integration of f of x y dy, f of x y dy that we are right, x plus y by 3 dy. Then in this is a 1 by 3, I am taking the common in the outside. Integration I am doing x plus y. I am doing with y. So I am doing with y. So x is a constant. So I am doing here x dy plus y dy. X dy plus y dx is a so see here. So x into that is y square. X into y multiply. I'm multiplying here x dy into y. So x is the constant here. Then y square by x dy, that is y square by 2. So y cube. Just a minute. I will clarify again. See here, x plus y by 3, x is the constant. I'm taking the output here. Integration of y dy, y square by 2. Integration of y dy by y square by 2, 0 to 2 to 3 here I'm taking here. But here x, y. So I'm multiplying here. That is the same y dy I'm applying here. X into y square whole power. So upper limit and lower limit 0, 2. So therefore, applying 0, that is a 2x. So this is a 0, this is a 2x plus a 2, 2x. This is a 4y. 2 into 4y by 2, we are taking 4y by 2, that is means 2. So 1 by 3, 2x plus 2. Here the output is came here. Again the common 2 of 2, we are taking the common of 2, x plus 1 by 3, we are taking here. So x plus 1, we are taking the tail. It's again, we are taking f of y, we are taking here. F of y, f of x by dy, integration of x plus y by 3. Dx now we are taking here. See the very graphical method you have to see here. In this one, we are taking the graphical method of y. In the x, we are taking the y is 0. So first of all, x integration of x square by 2. 1 by 3 I am taken already common here. 1 by 3 I am taken common already, x square by 2. Again in UV method we are taking here. Then integration of x into y is the constant, and x we are derivating here y into x square by 2. So 1 by 3, 2 to the 4 by 2, 2 plus 2y. So I am taking the common of this one. 1 by 3, 2 plus 2y. So 2 I'm taking here, 2, 1 plus 2y, 1 plus 1 by 3. Where 2x plus 1 by 3, 2, 1 plus y by 3. So therefore the conditional density function of x and y are given here, f of x y by f of x by y by f of x by y. So therefore the first condition is the problem here, x plus y by 3 here. I'm writing here, then f of y, that is 2 plus y 1 by 3. See here, this 3 get cancelled here. X plus y by 2 y plus 1. F of y by x, that is x plus y by 3. Then 2 into x plus 1 by 3. See in the top of the bottom. 2 into x plus 1 by 3. 3 get cancelled here. X by 1 by 2 x plus. So that is the reaching the variable here. X plus y is the same. 2 into y plus 1. That is a y variable we are taken here. This x variable taken here. This is the one problem. Check here. This one problem also. Check in the model answers also we can check here. The joint probability distribution of random variables x given is a find the marginal conditional probability. See here again -1 to 0 to 1. We are taking here example 2. So example 1 we are taking here. So total 1 more 3 plus 1 4 plus 2 6 4 plus 5 5 6 5 2 plus 3 plus 4 2 3 2 5 6 ఇక్కడ 6 plus 5 11 రావాలి 11 by 11 1 రావాలి 2 3 4 5 6 2 8 8 So see here, 2 by 15, 1 by 15, and 2 by 15 are 6 plus 5, 11. That's a 2, 3, 4, 3, 2, 5, 6, 6, 7, 9, 10, 12, 13, 14. See here, px1 by 8 by 5, 15 by 5, 14 by 5. Then we are taking the values. The same has been given here of the problem. What that is a want here. The second one example 2, the random variables x cube by y cube also you have to check. Not given here for exercise problems you have to do here. Then another problem. You know, to the most of the problems of most of the problems of this one, this is a current procedure you have to take here. Then independence of random variables we are taking here. So independence of the random variables we are taking here, independence of random variables. What is how we can introduce the same here? We can learn here. So independence of random variables depend on the both discrete and continuous random variables. So therefore, P of x y is equal to, we are writing P of x into P of y in case of discrete random variables. F of x y is equal to f of x into f of y is continuous random variables. The joint PDF of random variables x and y is given f of x y is equal to 3 by 2 y square 0, 0 less than r, x less than or equal to 0, 0 less than or equal to y less than or equal to 1. So check whether x, y are independent or not. The marginal PDF of x and y are given by, we are taking here f of x is equal to integration of y, f of x by dy. So see here integration of f of x by dy. What is the condition given here? So you have to see 3 by 2 y square is given here. So in the 3 by 2 y square, see here 3 by 2 y square. So I'm taking the common of 3 by 2 here. Common of the 3 by 2. 3 by 2 I'm taking the common of the here. Then integration of y square means x power n plus 1 by n plus 1. So we are taking y cube by cube, that is 0, 1 is the lower limit and upper limit of the equation. We are taking 0, 1. So apply 1 by 3. 1 by 3 here, you see here, this is 1. So 1 by 3, 3 get cancelled here. So 1 by 2 is f of x we are taking here. But then immediately we are going here. F of integration of f of x y dx, 3 by 2 y square dx. Again we are taking here in respective of y square we are taking here. So therefore in the respective of y square we are taking here. So 3 by 2 y square, there is no x square here, there is no x value is there, but x is there. So 3 by 2 y square is a constant. Integration of dx is x 2 power 0. It is taking place of x, that is 2 get cancelled here. 3 into y square is equal to 3y square. Automatically we write here. So therefore the condition of the independence f of x comma y is equal to f of x into f of y. So we are writing here 3 by 2 y square is equal to f of x y. F of x y is the problem. We are given 3 by 2 y square, f of x y given here. We are writing 3 by 2 y square. Then 1 by 2, that is the 1 by 2 is the 1 by 2 is the x value and 3 by y square is the y value. So that is, we are writing 3 by 2 y square. Both are same here. You have to take here f of x and f of y. We are multiply f of x. So what is the given problem? Both we can multiply at the end of the problem. So the f of x comma y, f of x and f of y is the two random variables x and y are said to be both are equal. Then only are it independent here. Then another one problem we have to do here. The bivariate probability distribution x and y is given below. Check whether x and y are independent. The bivariate probability distribution of x and y is given. Check whether x and y are independent or not. We can check here. Minus 1, 0, 1, 0, 1, 1 by 15, 2 by 15, 1 by 15, 3 by 15, 2 by 15, 1 by 15, 2 by 15, 1 by 15, 2 by 15. We are checking here. See here, all of you. X is equal to minus 1. See here, 6 by 15. 1, 3, 2. There is 6. 2, 2, 1, 5. 2, 1, 3, 4 by 15. See here, we are in the call, we are, if x is equal to 1, minus 1, y is equal to 0. So you have to check here 2, 3, 1. This is the minus 1 we are taking, that is 3, 2, 6. There are columns we are summing and the value shows. And then y is equal to 0, right here 4 by 5. Y is equal to 0. 1, 2, 3, 4 by 15. 1, 3, 2, 1, 6. 2, 1, 2, 2, 1. 5 by 15. See here very clearly what we are taking here. So therefore the condition of the independence of that one P of xy is equal P of xy is equal to P of x into y. So otherwise xi were independent here. So P of minus x minus 1, P of x minus 1 and 0 is 1 by 15. P of x minus 1, 0 is 1 by 15. But P of minus x1 into 0, we can multiply. So both the values are not same. So therefore xy is not independent. Even one condition should not satisfy here. Even one condition is also not satisfied here. No need to verify the remaining conditions 0 and 1 and 2. Another problem we have to check here. One problem we have to check. Another problem. The random variable x and y follow the probability distribution. Examine the independence of random variable x and y. The joint probability function. The first one here, see here all of you. That is 0.10. That is 0.15. We can multiply with 0.45. 1010 means 0.45. Again that 0.5, that is we are taking here 0.5, 0.51. That is 0.2, 0.5, 0.51 and 0.2, 0.5, 0.35. That is 0.35 plus 0.1 plus 0.5, 0.5. That is 0.1 and 0.2. 0.3 we are writing here. Again the conditions we are using here. Then the condition of the independence of x comma y is equal to 0 comma 1 we are taking here. So x comma 1 y is equal to 0 comma 0.05. So x is equal to 1, y x is equal to 1 and y is equal to 1. X is equal to 1 and y is equal to 1, 0.1, 0.1. We are taking here 0.2. So both are not independent. That is 0.05, that is 0.05. So x and y are not independent. So f of x and f of y and f of x comma y are multiplied the same. Is independent or not, we can cross checking here. Again, the marginal PDF of x and y. F of x is equal to 2x into e power minus x square. 2 into e power minus y square we are taking here. The condition of the independent f of x y is equal to f of x into f of y. Since 4xy into e power minus x square plus y square, that is 4xy e to e power minus x square plus x square, what we are taking here. So we can detaching the equation here. So detaching the equation here. 2xe, that is 2xe e power minus x square 2 into 2, 4xy e power, and I'm x and y are separating here. Therefore, these two are independent. Why? Because 2x e power minus x, so 2y e power minus y square. So x is separated and y is separated, but both are independent. So therefore, we are writing here both are independent here. This is the condition. So define the independence of the random variables. The joint point of random variables also we can take here. The 7th unit. Expectation of function of random variables. What is the mathematical expectation of random variables? And the properties of mathematical expectation also we can learn in this unit here. So see here what we have to take here. Mathematical expectation from random variable. So many frequently using random variables can be effectively used for practical purpose by considering the quantities called expectation. Expectation is considered as the average value of the by random variable. So a gambler might be interested in his average winnings in a game. A businessman is interested in average profits in a product and so on. The average value of a random variable considers mathematical expectation of random variable we are taking here. See mathematical expectation of a random variable. Let x be a random variable, then its mathematical expectation denoted by e of x. So what is the e of x and e of x square in the mu 1 square, mu 2 square? You learned on the earlier in the first semester. E of x is equal to summation of x, x, p, x. X is a discrete random variable, but the integration of minus infinity x of x is a continuous random variable. So discrete in continuous random variable, that means it is an infinite function. It is unless until go to the end, non-end the function. So it is an infinite function. It go to the values here. So provide summation of x, p of x, and integration of minus infinity to infinity modulus of x, f of x dx. The modulus of x means it is negative. Also, we can take the positive value. That is f of x dx. It should be exist here only. Here, p of x probability mass function x discrete is the random variable. The pickup in the random variable. F of x is called as probability density function x continuous random variable we are taking here. Expectation of a function of random variable. If g of x is a function of random variable, then expected value of g of x is defined as e g of x summation of x g of x p of x. X is a random variable. P of x is a probability mass function. See here, summation of x g of x and p of x. X is a discrete random variable. When we are taking it, it's a summation. But in the integration, x is a continuous random variable. F of x is a PDF. So here very crucial here. Summation taking that is p of x is PMF, but it is a discrete random variable. But integration of minus infinity to infinity g of x dx continuous random variable in f of x, that is a discrete lo px అవుతుంది, ఇక్కడ continuous లో f of x అవుతుంది, but it is a probability density function PDF we are taking here. What are the properties of the function we are taking here? E of c is equal to c. E of c is equal to c. If E of C is equal to summation of x, E C P of x. C is the constant. You know that all of you, that is the C is the constant here. You know that C is the constant here. C is the constant here. Therefore, summation of px, summation of x, px is equal to 1. So therefore, E of constant is equal to C. We are taking here only. So see here, property we are taking here, property what we are taking here, E A of x plus BG of x. So we are taking the common of A of x plus BG of x. So A of x plus BG of x we are taking here A into E f of x, that is A into E f of x. A we are taking B into E g of x, we are taking A into A f of x plus B into g of x. Summation of x, we are taking summation of A of x plus BG of x, and we are taking P of x, we are taking here. The condition we are applying here. Summation of x, A of x plus P of x, B, G of P of x. So in the constant, we are taking A is the constant. Summation of f of x, P of x, B, summation of G of x and P of x. So A is the constant, that is we are taking here A f of x and B f of x. So therefore, this the condition should be solved here. A f of x and B f of x we are taking here. Next, movements about origin. The expectation of x power r, known as earth moment. Earth moment about the origin, it is denoted by mu r. It's a mu r dash e x power r. Summation of x power r p of x is x is discrete random variable. Again, integration of minus infinity f of x dx, x is a continuous random variable. You know that summation of x is taken as discrete random variable. Integration of minus infinity to infinity, that is taken as continuous random variable we are taking it. Central moments. Central moments. In central moments, x bar mean of x, then expectation of x minus x bar whole power r is known as r central moment, is denoted by summation of mu power r e x minus x whole power r. That is, we are writing here e summation of x minus x bar whole power r p of x is discrete random variable. Integration of minus infinity to infinity x minus x whole power r f of x is a continuous random variable we are taking here. So some of the important statistical constants in the notation of the expectation we are taking here. X bar is equal to summation of x of p of x. Summation of x of px we can write as e power x. So e power x, that is the mean we have writing, that is here, that is a writing here mu1 dash, that is a writing here mu1 dash. Where in summation of x minus x bar whole square, that is p of x is equal to summation of x square of px, that is minus summation of x px whole square. There is a mu2 is equal to mu1 dash whole square minus mu1 dash whole square. Every time there is a value should be 0. mu2 dash mu1 dash minus mu1 dash whole square. mu1 dash minus mu1 dash, there is a value should be 0 here. But mu2 is equal to mu2 dash minus mu1 dash whole square, that is e power of x minus x bar whole square. You can write here that the condition e of x square minus e of x whole square we are writing here. The ortho moment of the point A is we are writing here. Ex minus a whole square summation of x minus a whole power or p of x is a discrete random variable we are taking here. Integration of minus infinity to infinity x minus a whole power or f of x is a continuous. So summation it is a taking of discrete random variable, infinity taking as a continuous random variable we are taking here. Relation between moments and about origin and about mean we have to discuss here. Mu power r e of x minus x bar whole power r e of x power r minus taking the NCR condition RC1 x power r power minus 1 of x, then RC2 x power minus r power to x bar whole square, and so on. The condition we are taking here minus 1 whole power k, that is RCK NCR, that is k x into r power minus k, the nth condition we are taking here x bar whole power k, and so on, plus minus 1 whole power x bar whole power r we are the condition taking here. So what is that condition in the next step? E x minus x power whole power r we are taking, that is e x power r we are taking here. See here, this is the e x power r. So that is the e x power, I am simplifying here, e x power r. Then RC1 x power e into multiplying here e into x r power x into r power minus 1, RC2 x minus r power minus 2 x bar whole square, and so on, minus 1 whole power k. E power, I am applying e here for all these values here. So that is a minus 1 whole power r, minus 1 whole power r, a whole power r e power 1 we are not taking here. So therefore, mu r dash 1 RC1 mu 1 dash and mu r1 minus dash plus RC2 mu 1 dash mu r2 mu r minus 2 whole power dash, so on, minus 1 whole power k ck mu 1 dash whole power k mu r minus k whole dash minus 1 whole power r mu 1 dash whole power r we are taking here. Mu 1 dash we are taking e x power r, that is e is equal to x minus x bar plus x bar whole power r we are taking here. So the condition e x minus x bar whole power r, NCR condition I am taking again RC1 x minus x bar r minus 1 x bar, RC2 x minus x bar r minus 2 power low, but x bar 2 అంటే మనం ఏమైతే వాల్యూ ముందు తీసుకుంటామో దాని x bar x square x cube bar లో తీసుకుంటాం. RCK x minus x bar r minus k x bar whole power k plus x bar whole power r, that is condition mu r, RC1 mu r mu 1 dash, RC2 mu minus 2 mu 1 dash whole square plus RCK mu r minus k mu 1 dash k plus r1 mu dash whole. Then covariance using expectations we have to take here. So what is a covariation? If x and y are two random variables, then covariance between variables x and y defined as covariance of x and y, e of x minus e of x minus e is the common x minus e of x and y into e minus y. This is the covariance of y we are taking here. So therefore e of x minus x bar and y minus y bar, see here we are taking this condition here, this is x minus x bar and y minus y bar, x and x into the e of x and x bar, y into the e of y and y bar. So see here, multiply them, e is equal to xy and xy bar, and y x bar by multiply and x into y xy, x into y bar minus xy bar minus of x bar y minus into minus plus x bar y bar. What is the condition I am writing here? Then we are simplifying here, e of xy First one we are taking e of xy. Then e అలానే ఉంటుంది, y ని కాన్స్టెంట్ గా తీసుకుంటాను నేను. y taking y bar e of x. ఇక్కడ x బార్ ను బార్లు ఏవైతే ఉన్నాయో బయట తీసుకొస్తున్న x బార్ e of y. ఇక్కడ ఈ బార్ ఆఫ్ రెండు బార్లు ఉన్నాయి కాబట్టి e of x బార్ y బార్ బార్లు ఉన్నాయి మాత్రం మొదలు బయట తీసుకొచ్చాం. ఇక్కడ రెండు బార్లు ఉన్నాయి కాబట్టి రెండు లోపల యాజ్ టీజ్ గా మనం కండిషన్ ని యాజ్ టీజ్ గా పెట్టేస్తాం అక్కడ. సో e of xy minus y. సో see here y e bar x. So this is ex అంటే x bar, ey అంటే y bar, y bar x, x bar y. So x bar y bar e of y అంటే 1 కాబట్టి e of xy see here minus xy plus xy 1 అంటే 1 కాబట్టి e of minus yx as it isly we are taking here. We can write as it isly here. So therefore e of x minus e of xy minus e of x ey y bar x as is రాసుకుంటాం. Then we can prove one theorem here. Let x and y, two are independent random variables, covariance of x and y. We are taking here covariance of so therefore x and y are independent random variable, covariance of x y 0. So what is the problem here that we are taking here? So x and y is taking here two independent random variables associated with the same random experiment here. Let x and y the joint probability mass function of x and y. We know that x and y are independent. P of xy is equal to p of x into p of y. We know that here. And p of x and p of y are marginally probability function x and y respectively.
प्रवेश करना वर्ष 2025 को मैं 100 वर्ष का हो जाऊंगा. वर्ष 1925 में विजयादशमी के दिन नागपुर में डॉक्टर
x and y the joint probability mass function x and y. We know that x and y are independent. P of x or p of y, where p of x and p of y are marginally probability mass function of x and y respectively. So therefore now e of xy is equal to, we are taking summation of x and summation of y, where xy is equal to p of x comma y. So therefore already I told you summation of the discrete random variable, we are taking summation of x and summation of y, we are taking here. So therefore summation of x and summation of r, xy taking here, see here xy I am taking here xy p x summation of r rpy. So this is the r is the common rpy, and rp of x and rp of y we are taking here. This r xp of x is equal to summation of x, and so rp ypy that is equal to summation of y. Therefore x and y both are independent. Why? Because already told you in 4xy e power minus x square, we are taking 2x into e power minus x square and 4y into e power minus x square. So multiply 4xy e power minus x square. The both are x and y are independent here. So both are same. E of xy is equal to e of x into e of y. We are writing here. So e of xy minus e of xey is equal to 0. Both the values, the covariance of xy is equal to 0. We are taking here. So that's another theorem one we have to taking here. If x and y are two random variables, then show that e of x plus by is equal to a into e of x. A is the constant we are taking here. A is the constant we are taking here. A into e of x. B is the constant b of y. So let x and y be the random variables f of x and f of y, the probability density function of x and y. So e of x plus dy, that is integration of minus infinity to infinity. Then integration of minus infinity to infinity x plus dy, xy dx dy we are writing here. Where f of x is a joint probability density function. So a is the constant. Already I told you I can write a is the integration of x to x, and y f of x dy dx. So first we are doing with integration of y, not x. After this integration of y, then we are doing integration of x. Then here also integration of x to doing, then we are doing integration of y. So first integration of y, integration of dy, integration of x or dx. You can do first y x to dx or y to dy. First we can do the y and then x, or x to do the first, or then you can do the y of the next here. See here. So therefore, integration of x f of x dx y, integration of y of d of y. So therefore you know that earlier problems, or you know that x d of x is equal to x integration of x dx, this one. So therefore a into f of x dx is equal to 1. So that is a into e of x. Integration of y d of y is equal to 1. Therefore f of y, that is b into f of y. The condition is satisfied automatically here. Theorem, one theorem, another theorem we can learn here. The x is a random variable and a is a constant, then show that e a phi of x and integration of minus infinity to infinity a phi of x f of x dx. See here, a is the constant here. So a pi of x, so a is constant, integration of pi of x plus f of x dx, a into e. So we have to taking here a phi of x dx, f of x dx. So therefore the condition should be the same here.
Thank you, sir. I now ready.
So that if x greater than or equal to 0, then e of x greater than or equal to 0. So therefore, if x is a continuous random variable x greater than 0, e of x is equal to integration of minus infinity to infinity x f of x dx. So since x greater than 0, f of x greater than 0, so we have to take the always e of x greater than or equal to 0 for x greater than or equal to 0. This condition should be satisfied here. Then theorem, if x and y we are taking here two random variables x less than y and e of x less than or equal to ey. So x less than y, x minus y greater than 0. By applying mathematical expectations, e of x minus y less than or equal to 0, that is e of x equal to e of y, that is less than or equal to e of x less than or equal to e of y, we are taking here. Find the expected number of heads and tossing the three coins. One example we are taking here. So let x be the random variable heads 0, 1, 2, 3. X is equal to 0, 1 by 8. X is equal to 1. Both are less than 1 sign 3 by 8, 2, 3 by 8, 3, 1 by 8. This is the writing 0, 1, 2, 3, 1 by 8, 3 by 8, 3 by 8, 1 by 8. They are writing here the same.
Officials to make total open education free district. The program is free telecast here. You can even share the link with all your friends and if you like to watch this all India Women's Academic Conference.
So therefore, P of x summation of x is equal to 0 to 3 x px. So 0 into 1 by 8, 1 into 1, 1 into 3 by 8, 2 into 2 by 2 into 3 by 8, 3 into 1 by 8 we are taking here. So therefore 3 by 6, this is 0, 3 by 8, 3 into 6 by 8 plus 1 by 8, that is 12 by 8, that is 3.2, that is 1.5. This is the major function, this one. then the probability distribution of x3 minus 6, 9, 1 by 6, 1 by 2, 1 by 3. E of x square plus E of 2x plus 1 whole square we are taking here. E of x is equal to summation of x is equal to minus 3 to 9 xp is equal to x. So minus 3 into 1 by 16 minus 16 to 1 by 12 9 into 1 by 3. So therefore you have to take here these are values of the simplification of E of x is equal to 3. This is 6 by 2 3. This is plus 9 into 3 by 3 that is 3. That is 3 1 by 2. This is a plus we have to take here. All the plus values 3 by 2 here. That is 2 5.5. We maybe should the value. Summation of E of x square, summation of x square, P of x 3 square into 1 by 6, 6 square into 1 by square, 9 square into 1 by 3. What we are doing is square here, 3 square, 6 square, 9 square we are taking here. So all these are plus, this is a plus, there is no minus here. This is a plus, there is no minus here. So 9 by 6, 3 by 6 and 81 by 3, that is 93 by 2, that is 46.5 we are taking here. E of 2x plus 1 whole square, E of x square, 4x square plus 1 plus 4x, E of 4x square, E of 1 plus E of 4x. Then 4e into 4 is a common 4e into x square plus 4e 1 is 1. Then 4 into e into x. 4 into e of x for 46.5. Then 4 into e of x is equal to 5.5. 46.5 into 4 plus 1 into 4.5 that is 209. This is the basic fundamental. This one. In this unit, we schedule mathematical expectation random variable, mathematical expectation of the random variable. We are taking here the mathematical expectation. We have also studied certain property of mathematical expectation. So this is the one. Tomorrow we will discuss of the 8th unit central moments and covariance from tomorrow. Any doubts, ask me. Rakesh Sagar, listen.
Yes, sir.
Tomorrow by sharp 10:30 you can join. Tomorrow say 8th and 9th unit. Tomorrow we will discuss. Okay.
Sure, sir. Sure.
Next Sunday we can discuss another 3 units.
Sure, sir.
Any doubts, ask me. I will clarify.
Sure, sir.
Okay.
Sir, can we get that PDF, sir? Hello. Hello.
Hello.
Sir. Sir.
చెప్పండి.
Can we get that PDF, sir? ఆ PDF అంటే షేర్ చేసి
పంపిస్తానండి.
అంటే నేను
Last day I will
గ్రూప్లో
share. Last day I will share you.
ఓకే సార్. ఓకే.
Okay.
ఓకే సార్. థ్యాంక్ యూ.
Right. Any doubts, ask me.